Hey everyone. This question was asked in class today, and it turns out it's also question 4 on page 347. I'll go ahead and try to give an answer, and my argument is going to be almost exclusively algebraic. I think there would be there are other types of arguments that could be made, maybe one geometric and so on. But so the first thing I'm going to do is just substitute the term in. So as you know, the details of the algebra and arithmetic, I can make mistakes in often. So I'm going to try to hammer through this with no mistakes in one video try, and we'll just see what happens with that. So the first thing I want to make, this is a very useful note for this. If I have something like x minus a cubed, that always multiplies out to be x cubed minus 3ax squared plus 3a squared x minus a cubed. You might remember that, and you might remember some of the connections to Pascal's triangle or combinatorics that we see there, the pattern 1, 3, 3, 1 on the coefficients, the increasing and decreasing exponents on the a and the x term, etc. But I'm going to use that to help me multiply out the x minus b over 3 cubed. So that term, the x minus b over 3 cubed, that multiplies out using this process that I wrote right here. So I have x cubed minus 3 times the a term, which is b over 3, times x squared, plus 3 times the a term squared, so that would be b squared over 3 squared, times x, minus the a term cubed, b cubed over 3 cubed. Okay, that is just the x minus b over 3 cubed. I'll put parentheses around that to help it stand out. Then I have the next term, b times x minus b over 3 squared. So I'll multiply that out next. Relying on what I know about multiplying out a perfect square like that. So I have x squared minus 2 times b over 3 x plus b over 3 squared. So that's b squared over 3 squared. Plus, well, this one starts getting easy. Cx minus bc over 3 plus d. Next thing I want to emphasize is here and here are the only place x squared terms appear. So I'm going to totally cheat, and I'm only going to pay attention to those terms next, because that's what we're interested to see what that they cancel out, I guess. Right, so in essence, I'm trying to pay attention to, I believe, those two terms. So this one, the 3 and the 3 cancel out, and I have, in essence, I'm subtracting bx squared, and over here, I am adding bx squared. And again, there's no other x squareds anywhere in all of that. I'm not going to carry out any more algebra. I'm just going to say we can now see that using the horizontal translation to the right of b over 3 cancels out the quadratic term. Hope that's helpful.